Welcome to the lecture. In this video, we are going to talk about the third data transformations method, which is the reduce method. So in the previous lectures, we discussed that we use the reduce method to essentially boil down all the elements in an array to one single value. And also we have discussed an example that adding up all the numbers in one array. So let's try that now with the all moments array. Now let's write here console.log moments reload. So see here, this is our array. So here, this array, we have to do that adding up all these numbers. That is both the deposits and also the withdrawals. We end up with the global balance of the account. So let's write here, use the reduce method, moments dot reduce. And the result of the reduce method will be, as I just said, the global balance of the account. So let's call the result in, right here, const balance equal moments dot reduce. And remember that in this case, this balance will be simply one value and not an entire array. So the reduce function also gets a callback function. Let's write here function. Now here there is one a little bit different from the other ones, like the one in map and for each. So in this here, the first parameter is always the current element of the array. So that is current element. And the second one is the index. And the third one is the entire array. But here in the callback function of the reduce method, the first parameter is actually something called the accumulator. So that's why I'm giving here the accumulator shortest form like this. So this accumulator performs that keeps accumulating the values that we ultimately want to return. So in this case of adding all the elements or all the numbers of an array together, that will be the sum. So now, but anyway, let's write the actual function block. So as always, this callback function here will be called in each iteration of looping over the array. So reduce also loops over the array and calls this callback in each iteration. But now what we will actually do in each of these iterations means the accumulator is the value that we will keep adding to what we are going to add the current value to the accumulator. So let's write here accumulator plus current value, and this works because in each of call of the callback function the accumulator will be the current sum of the all previous scales, and so we will really keep adding to the accumulator in each iteration of the loop. So for that, just write return. So this is how the new accumulator can then be used in the next iteration of the loop. So basically in each loop iteration, we return the updated accumulator. So the current one plus the new current value. And so like this, we can keep adding to it in the next iteration. So this callback function is the first argument of the reduce method. But the reduce method actually has another, so a second parameter. So that is the initial value of the accumulator. So the value that we specify here, which is this case is here, I'm giving 0. So this 0 is going to be the initial value of the accumulator in the first loop iteration. And so in the example, we want to start counting or we want to start adding at 0. So therefore, we simply specify 0 here. And now let's log this into console. Balance. See the result. See here we have one single number, that is 3840. So with this, indeed everything was boiled down to this one number, which we can suppose of all of these values here added together. And to make this even more clear to see that, that's actually always log the accumulator to the console. So for that, let's write here console.log let's say that iteration number. So instead of this, write like this I, and then give the accumulate. And now we see that in iteration 0 the accumulator is 0. So let's see the reload. So now we see that in the iteration 0 we see that the value is 0. So this value that we specified here, so as the starter, as the initial value, then in the second iteration the accumulator is 200, that's the value, plus the current value in the previous iteration, so that is 200. And so this 0 plus 200 creates the new accumulator which is done in the next iteration, that is 200. Then in this iteration we add the current value which is 450, that result is 650, and then the value of the accumulator. So here you can really see like a snowball effect of all of these values adding up to one final value. So at the end, the value is essentially accumulator. Now here we see the value of going down because in this iteration we are adding minus. So that's why here 250. And also here in the last iteration we have 2540. Then adding 1300 to this 2540, so that we get 3840. Now for suppose if we change this value to 100, then let's see the effect of changing this. Reload. Now we see that the iteration 0 is being 100. And so we already started with a small snowball here that we are keep adding to, and therefore our final balance is now 100 euros. So let's keep it 0. So this is all this, and now let's do the same thing for using the for of loop. Write const for const moment of moments. And so now here we have an global variable. Let's create that. Let I'm giving balance 2, that is equal. I'm giving the initial value 0. And so essentially this is initial accumulator value just like this 0, and then sum plus equal the current movement. So let's write that here. And now the statement is that balance 2 plus equal current movement. So that is here move shortest form, and then log this into console. Balance 2. Now let's see the result. Reload. See here we have the same balance. We see that here we have the same pattern that we always need an external variable whenever we want to use for of loop. That's fine if you only need one loop, but it start to become really unpractical when we use many loops for doing many operations. So these methods that we have been studying, they completely avoid this extra variable and they simply return the variable or the value actually right away. And of course, we can write here in an even simpler way like this one. So because of that, using the array function that we can see the return that's happening. So let's copy this one again, paste here. Let's comment this one, comment. Let's get rid of this function. And so this is also we don't need. But here always we use or the need of the accumulator and the current value. So here we need parenthesis and then the arrow, and then we always get rid of all of this return also accumulator plus this curly braces also. Now this is fine. Let's reload. See here we have the 3840, that is the same result. So the working of reduce method is something really important. And now here we can actually calculate the balance also of these movements here and then print that balance. Right here to our application and user interference. And so let's go ahead and do that. So that is here in this application. Let's write here const create a variable calculating print giving balance that is equal giving function, and so this function here will once again receive the movements as an input. So write movements. So any array of the movements will work. Now let's calculate the balance based on this array. Let's write const balance that is equal movements dot reduce. So remember that the first parameter here is now the accumulator. So that is accumulator. And then the next one, second one is the current value. So CUR. So now here in this case, I am giving the current value as a moment move, and then I am using the arrow function, and here simply we return the accumulator and then plus moment 0. Now let's reload. Now we see that here these elements we have balance, and in this balance value we have the balance value. So the balance value that we have already mentioned here in this label balance, that is this balance value, that is where we simply want to put some text. So for that let's write that here label balance dot text content that is equal balance. We simply give balance or use the literals balance, and then we need the euro. So EUR, that's it. And so now let's see, of course, we don't call the function yet. So let's do that. Actually, let's put this function, just copy this, cut this function, and then place this in account one dot moments. Place here. So here we are doing all this in display. So here I'm changing the name to calculating display balance. Now let's call the function calculating display balance, and then here I am giving the account one dot moments. And after doing this, as we keep developing this application later on, so of course these movements here that are going to will be from the account that logged into the application. So if the owner, that is Jonas, will be logged into the application, then Jonas movements will be shown and Jonas balance also. And but if Steven logs in, then of course then Steven movements and Steven balance will be shown here. And right now we already see our balance here. So this actually happens to be exactly the same what we calculated before. So let's see this. See here we have 3840, because the movements that we are having here, that is nicely developed. We actually already completed some parts here of our flowchart. Let's open the flowchart. See that we can keep looking at it. And so we already did calculating the balance and displaying the balance. And we all this in just one function. And we also already have displaying the movements. And indeed we are making some nice progress here, and the rest that we are going to be even easier as we go on. Let's close this one. And so now let me show you that one more example that we are adding the values. If we are doing again adding means that was boring. So this time I want to do is to get the maximum value. So let's write here. This is for maximum value. So now here in this case the result we are looking for, this is 3000. And so for that we can also use reduce, because remember reduce is for boiling down the array into just one single value. But that value can be whatever we want. So it doesn't have to be sum. It could be a multiplication or even something completely different like a string or an object. But here we will keep working with the numbers, but this time we want the maximum number. So let's kind of go manually through this array to determine what the reduce method should do. So let's start here at a 200. This is the maximum value at this point? We don't know it because we just started. So let's save 200 here mentally as our current maximum. So then we move on to the next value, and now see we have 450. So this is greater than our current value. So as it is greater, so now 450 is now our current maximum value. So then 450, and so here 4 minus 400. So minus 400 is not the maximum value based on this 450. And so again we have 3000. So 300 is a greater than our current maximum value. So that becomes the current maximum. So we store this 300, 3000. Then we keep the value. There is no other value greater than 3000. So in the end, our maximum was this one. So 3000. And now all we need to do is essentially translate this into code. Using the reduce method, write const max equal movements dot reduce, and then accumulator, now with the current value, move. And then here I am using the arrow function. Now this time, what should be the purpose of this accumulator value? Means that's always the big question, that when we reduce, when we wanted to add all the numbers together, the purpose of the accumulator in previous section. So here the accumulator will be the one that will keep track of the current maximum value. So let's just start by writing the logic. So to make this a one-liner function one more time. So translating the logic is accumulator that is greater than, which is the moment, then return the accumulator. So next return accumulator, because in this reduce method we always have to somehow return the accumulator to the next iteration. And in this case we simply want to keep the accumulator at the value that is already is and not change it. So we want to change it in the other scenarios basically. So for that, else when the current value is greater than the accumulator, so that would be the current value is 450 and but the accumulator is 200. So now the moment is greater than accumulator. So what we want to return here is the accumulator. In the next iteration is the current value. So here else we need to return more. And now we also need the initial value here. So the first value here of the array, and so that's moment at position 0. So that is we want to write here moments of 0th element. And then let's log this into console. Max. Now let's see the result. Reload. See here we have the value, the maximum value, that is 3000. So here basically we started at 200. In this iteration is the accumulator greater than the movement. So well, it is not. So return the current movement. But the first iteration is that it gets interesting here in the second one. Now our accumulator is at 200 and the current value is at 450. So this one here is a false again. And so now we return to movement as the new accumulator in the next iteration. Alright, so in the next iteration, this accumulator is 450 now. Now here the current value is a minus 400. And so here 450 is greater than minus 400. Yes, of course, that is correct. So let's simply return the accumulator. So that is say that the same logic, that's the logic all the way here until the end of the array. By this, we then end up with the maximum value. So I hope that would be understandable. So I hope that now you have a better clarity about how the reduce method works on this. And so this is all about the session. See you in the next one. Thank you.